Hi, welcome. I'm Mrs. Dunn, and today I'm going to teach you a little bit about factoring. So we're going to do a brief introduction to factoring. What you're going to learn in this screencast is how to factor out a GCF and how to factor by grouping. So in my first example, and I'm going to go through 6 examples. So in this first one, we are asked to factor 24x to the 5th minus 30. So the first thing we want to do is try to find a greatest common factor, a GCF. So if you think about the number 24, that could be factored into 6 times 4 and 30 factored into 6 times 5 because I'm looking for that GCF, and the GCF here is 6. That's the common factor in both of those terms. So I'm going to factor out that common factor of 6, and what's left behind when I take these 6's out is 4x to the 5th minus 5. So this is the answer. This is that expression completely factored. You know you're correct if you check it by multiplying. So remember we were supposed to factor 24x to the 5th minus 30. So if I use the distributive property and distribute that 6, I get back to where I started. I know I'm right. Okay, so in example 2, we're factoring 7a to the 4th plus 18a squared. In this problem, I can factor a to the 4th into a squared times a squared. Now I realize there's a lot of different ways that I can factor that, but I'm looking at this factorization because then I see the GCF is a squared. And so when I factor out a squared, 7a squared plus 18 is left behind. So this is the answer, a squared times 7a squared plus 18. And once again, I strongly advise that you check your answer. Check by just using the distributive property, and you'll see we get back to where we started. Okay, look at example 3. In example 3, I've used this example for one specific reason. It has a negative as the lead coefficient. So this leading term has a negative sign. And when we are factoring, we want to make sure that leading term is positive. So we're going to factor out a negative. Now, if you'd like, pause the screencast and see if you can figure out what the GCF is. Look at the numbers 24, 32, and 8. Find the greatest common factor among the numbers, and then find the greatest common factor among the variable terms. Pause the video if you'd like. Did you think the GCF was negative 8y cubed? Now, it's negative, remember, because like I said, there was a negative leading coefficient. And then the greatest common factor between 24, 32, and 8 is 8. And the greatest common factor among y to the 6th, y to the 5th, and y to the 3rd is y to the 3rd. So that's what I'm going to factor out. So if I divide each of these terms by the GCF, negative 24 divided by negative 8 should be a positive 3 here. So I fixed that. It should have been a 3 here. So it's negative 8y to the 3rd times 3y cubed minus 4y squared plus 1. And that is the correct factorization. And I encourage you to check that. Check by multiplying, and you'll see that you get back to where we started. Okay, in the next example, example number 4, we're going to factor b squared times b plus 4 minus 7 times b plus 4. I chose this example because a lot of times students get confused by the parentheses. So right here, you're going to notice what's in the parentheses is the same. So the GCF here is b plus 4. So we're going to factor that out. Just like it's a single term, we're going to factor that out. And when I factor that out, what's left behind is b squared minus 7. So this is the correct factorization. And I encourage you to use the distributive property or FOIL, F-O-I-L, remember first, outer, inner, last, to check what that answer would actually be. And you'll see that we're going to get back to where we started. Okay, so that was all leading up to this idea of factoring by grouping. A lot of times students struggle with this factoring by grouping. So check this out. We're going to factor x cubed plus 5x squared plus 5x plus 25. Notice there is no GCF. Well, actually, the GCF is 1, but there's no GCF other than 1 that we can factor out of any of these terms. So what we do is we group these terms together. So we're going to put the first two terms together in parentheses. Keep this addition sign, that's important, and group the second two terms. Now look for a GCF among those two groupings. The GCF here is x squared, and the GCF here is 5. So when I factor out x squared, I get x plus 5 left inside. And here, I factor out 5, and I get x plus 5. What's important is that these parentheses match. If these parentheses don't match, you can't do factoring by grouping. Now, this is a problem where they do match. So x plus 5 and x plus 5 are the same. So that's our GCF. And we factor out this x plus 5 term. What's left behind is x squared plus 5. Okay, let's do one last example. In this last example, I chose this one because there's a negative sign here. And that's extremely important. You have to be careful. So when you group these two terms together, you have 7x cubed plus 4x squared. But when you group the second two terms, you're going to notice that this sign changed. Remember, it was minus, now it's positive. That's because there's a negative in front of this parenthesis. Think about the distributive property. If we're going backwards, negative 21x and a negative times a positive will give you a negative 12. That's why we changed this sign. We're dividing by this negative. Now, factor each of these two groupings. We'll factor out an x squared in the first grouping, and we'll factor out a 3 in the second grouping. Notice that the GCF is 7x plus 4. So when we factor out 7x plus 4, what's left behind is x squared minus 3. Remember to always check your answers. Okay, that's it. Good luck. You should be in great shape for this first section.